Okay, so let's do part 2 of that enzyme lab. So in part 1, we looked at peroxidase and hydrogen peroxide, and we counted, well, we didn't count air bubbles, but we monitored how long it took for those discs to float based on the accumulation of oxygen. And so for now in enzymes part 2, we're working off of the same reaction. Enzyme plus substrate equals enzyme plus product, like it always does. This time we're working with peroxidase from a turnip. Doesn't really matter, except that it works better for this particular reaction. So last time we did yeast, this time we're doing turnip. But we have the turnip peroxidase plus the H2O2, so that's going to be your substrate. And it's going to be the same reaction as before, peroxidase plus water plus oxygen. That's the exact same reaction that we did with the floating disk reaction earlier. Here's the big exception, except we're taking this oxygen, and also in our test tube, we're putting in something called guaiacol. Guaiacol is an oxygen acceptor. And when guaiacol and oxygen get together, they produce something called tetraguaiacol. Tetraguaiacol turns colors. And that's what we're using it for in this case. What we want to be able to do is to monitor our rate of reaction based on color change of the reaction. So the color change tells you how fast the reaction is happening. We measure color change with a spectrophotometer. That's the tool that we use to quantify color. It's kind of one of those things where it's like, some people might see my sweater and think it's purple, some might think it's pink, some might think it's fuchsia. It can be a really subjective thing. Well, a spectrophotometer set properly quantifies colors, and we don't argue with numbers as much, and so that's why scientists like them so much more. So we're able to say, rather than saying, oh, that's light brown, or that's medium brown, or that's dark brown, we can say the absorbance of that color at 470 nanometers wavelength is this, and that's not an argumentative kind of thing. So that's the kind of the interest of what you're doing in this lab. Hopefully you've read your lab prep. If you haven't, I strongly recommend that you pause the video and you take a few minutes to read this, because it can be really confusing. Part of your pre-lab, and something I will be looking for when I come around to verify pre-lab, is that you have made a data table that tells you what goes in your 2 different test tubes. And it's going to tell you up here to use 2 test tubes, mark one substrate and the other one enzyme, and then it tells you exactly what goes in each test tube. I want you to make a data table. And here's a hint, if you ignore this thing on the bottom, that's the answer. That's what's going in each test tube. Your substrate test tube has DI water, hydrogen peroxide, and your guaiacol in it for a total of 7.5 milliliters. Your enzyme test tube has 6 milliliters of DI water and 1.5 milliliters of peroxidase. I'll show you, this is actually going to be a couple videos long today, this lab. I'll show you how to measure all of these things out. 0.3 mils and 0.2 mils can be real tricky if you don't know what you're doing, but I'll show you how to do it. We're going to remember that we need to prepare these 2 test tubes completely independent of each other. As soon as you mix them, the reaction begins, and as soon as you combine them, you've got to get them in that spectrophotometer, because you've got to be taking your measurements at the increments that I've indicated, or that I'll tell you about here in just a second. And so you're going to prepare these 2 test tubes, but you don't mix them together until you are physically standing in front of a spectrophotometer and you are ready to begin your experiment and you're ready to begin your data collection. So this is a part of your procedure. So get to this point and then move on to the next video.